A transformation takes place when an object is moved from one location to a different location or simply changes in size. Transformations are considered rigid or non-rigid. If an object does not change size or shape due to the movement, it is considered a rigid transformation. If the object changes size or shape due to the movement, the transformation is considered non-rigid. Here I have three examples of a rigid transformation, meaning the pre-image and the image will remain the same size. The movement will not change the size or shape of the pre-image once it becomes the image. So we have a translation, which means to slide, a reflection, which means to flip, and a rotation, which means to turn. These are three examples of a rigid transformation. Now, there is one example of a non-rigid transformation that we'll be looking at today, and it is called a dilation. So it's important when looking at transformations that you understand there are three types of transformations that are rigid: reflection, translations, and rotations. And then the one lone non-rigid transformation that you'll be studying or looking at will be called a dilation. And a dilation is where the size will change, but the shape will not change. So let's see if we can look at an example of a dilation. A dilation is a non-rigid transformation where the size of the figure changes while the shape remains the same. For example, you can see there is a 2 by 2 square here. And since this is a dilation, in this particular instance, it becomes larger. We call that an enlargement. When the pre-image becomes larger, it's called an enlargement. When the pre-image becomes smaller, it's called a reduction. So, whenever you have k, the scale factor or the multiplier is greater than 1, the picture will get larger. Whenever k is equal to 1, the scale factor that is, the pre-image and the image will be the same, or in other words, they will be congruent. The sides will have the same length and the angles will remain the same. And the pre-image will look just like the image. Whenever k is less than 1, that means the picture will get smaller. The scale factor is less than 1, so instead of the full size of a car, you scale it down to the size of a model car. And so when k is less than 1, that's what happens. The picture or the figure or the shape gets smaller. The change in size for a dilation depends on a multiplier called the scale factor k. The scale factor multiplies the coordinates of the 2D figure like so. You have k and then you have the xy value. Here it's just reminding you that k is equal to 1, and whenever k is equal to 1, the pre-image and the image will be congruent. Now, the figure will get larger if the scale factor k is greater than 1. The figure will get smaller if the scale factor k is less than 1. So let's recap. K greater than 1 is an enlargement. K less than 1 is a reduction. And if k is equal to 1, the pre-image and the image will be congruent, meaning the same size, same shape. The dimensions, the characteristics will remain the same. So now, let's look at the coordinate grid to see if we can better understand what a dilation is and what it does when you look at it graphically. So, in order to understand a dilation, we understand that the majority of the problems we will be looking at, the center of dilation will not be the geometrical center. Like, for example, if you look at someone's pupil, when they need to see better and there's not much light, the pupil gets larger about the center of the eye. And when it's too much light, the eye actually reduces in size and the pupil becomes small about the center of the eye. But when dealing with geometrical problems in a typical math class, the center of dilation will be the origin. I have it highlighted here at 0, 0. And we're going to look at this example where I have a circle approximately at 2, 2. If an enlargement takes place where k is greater than 1, notice how the figure gets larger and it has moved away from the origin. Enlargements in general, when we have the center of dilation at the origin, will move away from the origin. Now, in red, if k is less than 1, well, if k is less than 1, that means we're going to have a reduction, meaning the size of the figure is going to reduce and it will move towards the origin. Notice how the red circle, when k is less than 1, is moving towards the origin. And notice when k is greater than 1, the figure will move away from the origin as it gets larger. So a reduction moves towards the origin and enlargement moves away from the origin. So it's important to understand what we mean when we say the center of dilation. For the majority of the problems we'll be dealing with, the center of dilation will be the origin at 0, 0. It will not be the geometrical center of the figure. So, in enlargement, k is greater than 1, and it's moving away from the origin. When k is less than 1, it is moving towards the origin. And when k is equal to 1, the pre-image and the image remains the same size. The two figures are congruent. So if they give you a problem and say the scale factor is equal to 1, what do you know to be true? The pre-image and the image will be congruent. Everything remains the same. Now, in order to dilate a figure, it is best to use the algebraic rule. You just simply multiply k times the coordinates. So let's look at an example problem for a dilation. Here it says example 1, dilate rectangle ABCD if its scale factor is equal to 2. And of course k is equal to 2. And the coordinates for the vertices are A is negative 4, 0, B is negative 4, 2, and C is 0, 2, and D is at 0, 0. We've already identified that the scale factor is equal to 2. I have the coordinates or the vertices for my pre-image, and I'm just going to place right there that k is equal to 2, so I'll remember what to multiply by. So now I write my coordinates, use the algebraic rule, and simply multiply using the scale factor, and I have negative 8, 0. And then I take b, which is at negative 4, 2. I'm going to multiply it by 2 as well, the scale factor. And it's going to become larger as I would expect because it's an enlargement. K is greater than 2. I get negative 8, 4. And then 0, 0. Oops, actually I made a mistake here. So let me go back and change that to 0, 2. And now if I multiply 0, 2 by 2, I will get 0, 4. Excuse me. And now 0, 0, well, the multiplicative property is 0. Anytime you multiply something by 0, it is 0. So 2 times 0, 2 times 0, you get 0, 0. So now I'm getting ready to transform my pre-image to my image. A prime will be negative 8, 0. B prime will be negative 8, 4. And C prime will be 0, 4. And D prime will be 0, 0. Technically, I'm done. I can use the algebraic rule every time and dilate. I do not have to go on an XY plane and do this geographically. Not geographically, but geometrically, sorry. So now I have this rectangle, and I have the coordinates so that we can see that the two align. I've done it algebraically, but let's look at this geometrically. So if I take A and convert it to A prime, it will be located at negative 8, 0. If I take B and scale it up by 2, notice that the point is moving away from the origin. So B prime will be located at negative 8, 4. So the next task is to move C. C was located at 0, 2. Once I scale it up by 2 to make it larger, it also will move away from the origin. It's moving straight up, and it will be located at 0, 4. That is my C prime. And then D, well, it's at the origin. And 2 times 0, unfortunately, it's going to remain where it is, and D prime will become also 0, 0. Now, I need to connect the dots. So just by simply connecting the dots, you're going to see that the rectangle becomes larger. Let's see if I can find a little darker, thicker line here. I'll grab that one. Okay, so now I'm going to connect the dots. And as you can see, the rectangle has gotten bigger as we expected because the scale factor was equal to 2. And it's greater than 1. And anytime the scale factor is greater than 1, we know that the figure is going to get larger and move away from the origin. That is exactly what happened in this particular example. So now we have A, B, C, D prime. Once again, when k is greater than 1, we have an enlargement. When k is equal to 1, the pre-image and the image will be congruent. And when k is less than 1, we will have a reduction and it will move towards the origin in comparison when an enlargement moves away. Here's the algebraic rule. It's quite simple. I hope this helps. Thank you.